Okay, so looking at the results, let's get going. Let's get going. Looking at the results of the first assignment, there were the first chapter 8 assignment, the one I put up on Friday. I could see where there were some issues, and I totally understand why. Let me clear those up right away, first thing, and then I want to just plug in the last little bit, and that's it. That should be it. We're done with new material. The rest of the year, we can be down there. You can finish some things up, retesting, working on this stuff, getting questions answered, whatever. But let's take a quick look at some of the where people had little issues. This is kind of a tough one. I can see why. I'll make it easy for you, but I can see why people had a hard time with this. Because now here's what people would have tended to put on this. They would have tended to put, well, this is a bad example, I guess, but they would have, like, let's say that this red curve went through the x-axis or the y-axis at 2. They would have picked A to be 2, which seemed to make sense. But can anybody tell me what the problem is with that?
That would be
So it'd be decay. It'd be decay. And it would be the right value. Here, let me just pull one other quick, easier one just to kind of point at. So what if we just take one real quick, kind of a warm-up one like this? Yes. Okay, you're fine. Okay. Oh, not like that. Okay, let's look at this guy. Right here, please. Okay, so what about one like this? We have to write this growth or decay? Decay. Okay, so if we're writing a decay function, y equals a times b to the x, and then potentially we could even translate this thing, right? Okay, but this one is not translated, so we don't really have to worry about that. What's the value of a? 9. How come? What is a? Okay, it's the y-intercept or the initial value, right? So we can see right away that a is, yeah, and you got to be really careful with the scales on these, which is normal for exponential graphs. There's even special math paper that mathematicians and scientists and engineers use a lot called like log paper, where one axis will be powers of 10 and the other axis will be just normal digits, because exponential functions grow so fast that it's hard to use just a consistent scale. Like if I had just used a scale where vertically we went by ones and horizontally we went by ones, this thing would just shoot off the screen so fast that you couldn't really see much of it, right? So you got to really be careful with the scales. So, but a is 9, right? Now, what's b in this case? What does b mean? What do we call it? Constant multiplier. And that says a lot. Constant multiplier tells us what it does. It multiplies a value of the y value to get the next y value, right? So as x scoots to the right by 1, the new y value is what we get when we multiply by the constant multiplier. So what's it going to be?
5.
Not 5.
Oh.
And what do I multiply 45 by to get 9? Not 5. 1/5. Okay. Now we could have predicted here without even focusing on the problem, just by looking at the shape of that curve. We knew that b had to be less than 1, didn't we? Because it's decay, right? Decay is what we get when the value of b is between 0 and 1, right? So it's got to be a fraction less than 1 because we're making things smaller each time, right? If it's growth, b has to be greater than 1, right? So we know it's less than 1, and the easiest way to find out is just to take two successive y values and divide them. Either ask yourself the question, this times what is that, or literally just divide them. If I take a y value divided by the previous y value, simplify, right? Now, wouldn't it be easier, there's another moral to this story, wouldn't it be easier to pick two values that were integers if we could? I mean, I could use, it's going to work the same for any two successive y values, but if I pick 9 and 9/5, that's a little bit tougher, right? Because then I've got to divide 9/5 by 9, which still gives me a value of 1/5, but it's a little bit easier to do if you just pick integers instead. Either way, though, the value of b is 1/5, right? Everybody agree?
Yeah.
Okay.
Wait, I don't know if this does work, but the one in purple, could you have told it was 1/5 because that's a fraction over 5?
Well, you could, because you could have asked yourself 9 times what is 9/5? One
Okay,
fifth.
that's 1.
9 times
Okay.
1/5 isn't 1.5.
No, 9 times 1/5 is 9/5.
She's talking about the 145 negative 145 over the right left.
45 times 1/5 is 9.
Oh.
Okay. 225 times 1/5 is 45.
Okay.
Does that make sense? It's going to be the same every time.
Yeah. Wait, but
Okay.
there's always going to be that purple point, correct?
I
Or
mean,
not always?
always is kind of a bad word used.
But typically?
Yeah.
Because you could use that,
Yeah.
or is it more efficient to use
Well,
one of those?
you decide. It's up to you. Doesn't matter.
Okay.
Okay, so now let's finish this up. 9 times 1/5
X minus.
to the x, right? Okay, this is important though. Don't, please, you guys, seriously, you're not going to get this if you don't focus hard, because this is we're condensing this process a little bit in chapter 8. So we have not translated this. Why do I know we've not translated this?
Because the one is on the because it's positive.
Because A is where it crosses the y-axis, exactly. And if we're choosing 9 to be our y-intercept, then we haven't translated this, right? So it's just h is 0, and it hasn't been slid up or down vertically, so k is 0. So that's the answer, right there.
So what is X? Oh, X is just normal.
That's the variable, right?
And what does K mean again?
K is how far, like it always is, K is just the amount that we're going to translate things vertically. H is how much we slide things
And
horizontally.
nothing moves because it's right in the center.
Exactly, because 9, 0, 9 is the point that's graphed
Okay.
there, okay?
So if it was like 1, 9, it'd be plus 1.
Then it'd be, well, it'd be minus 1 because you're
Minus 1,
subtracting.
I meant, yeah.
Yep, very good, very good. Okay, so now what about this guy though? Oops, hang on, what about this guy? Okay, this one's a little bit different. What's going on?
So if the last one was translated, how would you have figured that out?
Well, that's what we're gonna do now. We'll look at a couple that are translated. Okay. So what about this one? Has this been translated?
Yes.
It has. It definitely has been translated. How do you know that?
Because it's 0 and 0.
Oh, okay. Look at these down here. Now, the asymptote is supposed to be, in other words, if it's not translated, I shouldn't say supposed to be because it is what it is, but if it hasn't been translated, what is the horizontal asymptote for an exponential
0.
function? Y equals 0. Yeah, the x-axis, right? But that's not the horizontal asymptote here. What is?
What's that A word you're saying?
Asymptote?
Yeah, what?
Asymptote is this.
Wow.
Asymptote means what's the value that it's approaching? So is there some line that it's trying to reach but never does?
Okay, I just needed to know what that meant every time.
And that's zero most?
It's for a non-translated exponential function, it would be the x-axis. But look here, it's not the x-axis this time. It's the line y equals -3. So it's been translated how far?
3 down 3.
Down 3. Good.
So H would be
I thought it
3.
was -3.5.
Say it again?
Why is it 3? Is it, I mean, -3.
Well, because it used to be here, this line, and now the axis, right, I mean the asymptote, but now it's down there, right? We just wanna know where is the horizontal line that serves as an asymptote for us? It's at -3, right? If I pick this whole thing up by 3, the red function, then it would be curving towards the x-axis.
Oh, I see.
Okay. Okay, but what we're gonna do here on this is when we're trying to come up with the function, remember what I told you guys on Friday, and maybe you do, maybe you don't, but it's easier to think of this, first of all, by ignoring the translation, just by assuming that this is the x-axis, right, to build the function. And then at the very end, we'll just tack on a translation. Okay, so what I mean by that is, if we're gonna match this to let's first ignore the h and the k, right? So if we do that, if we're assuming that this is the asymptote, let's pretend it's the x-axis. What would that make these coordinates right here? This one, instead of being 0, 0, would be what?
0, 3.
0, 3, right? Because it would now be 3 above the asymptote, right? So that would be the point 0, 3. What would this one be? -1, 6. And this one would be -2. What would 12? Whoops, sorry, 12.
What about the purple one?
And then the purple point too, we can even do that one. What's that gonna be? Instead of being -3/2, it's gonna be,
Oh, 1, 0. Positive 1. Positive 9.
all I'm really doing is positive 3/2. All I'm really doing is adding 3, aren't I, to the y value. So this one would now become the point 1, positive 3/2, right? And now we're doing the same thing we did last time, right? We're just trying to identify what is this function if we assume that this is the, relative to this horizontal asymptote. Pretend it's the x-axis. What do we get? Well, we get, what's A? 3, yeah, right. So that's A. 3 times, what are we doing? What's my constant multiplier? We're getting smaller by 1/2, aren't we? If I take any successive y points, to get from 12 to 6, I multiply by 1/2. To get from 6 to 3, I multiply by 1/2. To get from 3 to 3/2, I multiply by 1/2, right? So the b becomes a 1/2. It hasn't been slid horizontally at all, has it? So h is 0. So far, so good. Okay, but in reality, those aren't the points. It really was slid, wasn't it? It was slid how far? And we're done.
Oh, that's actually easier than I thought.
So
But
how do we
these
find,
equations are constant. You only have each value if it moves from the origin.
If it moves horizontally. And the good news is, you never, ever have to actually even have an h value. I'll give you an example. You don't have to ever consider anything to be slid horizontally. All you have to do is just pick the right value of a. But if it's slid vertically, you don't have a choice. This thing really was slid vertically. Okay, yes?
So when it just changed like left to right, do you have to change all the values like you did when k was moved?
All you'd have to, yes, you would.
Yeah,
You,
okay.
well, yeah, you would, yeah,
Okay.
yeah. We'll look at a quick example of that, but it's always optional. Yes?
so will A ever be will A always be a whole number?
It's up to you. I'll give you an example. Let's look at this one, right here. Okay. I want to just show you here that you can do this in multiple ways. You take your pick. Do I have to, has this thing been translated vertically?
No.
No. So what if we just assume it has not been translated horizontally? If we treat it as though it has not, and it's up to you completely, what's the value of A?
8.
No.
8/3.
8/3, right? Because 8/3 is the y-intercept, right?
Yeah.
Okay, so y equals a times b to the x minus h plus k. If h and k are 0, this just becomes y equals 8/3. Whoops, let me do this. Times, what's b? 3. How'd you get it?
You just multiply 8 times
Because I have
8.
24.
8 times 3 is 24. That would work. 24 times 3 is 72. 8/3 times 3 is 8. Either way, right? Okay? So,
When it's going up, it'll always be a whole number. When it's going down, it'll always be.
yes, going up, it's growth, it's always greater than 1. If it's
Okay.
decay, it's always less than 1. But greater than 0, it has to be positive. Okay, so then what's h? Well, 0, right? Because we picked the a value here to be on the y-axis, right? So we just would call that x, and it hasn't been translated vertically, so that's our answer. That's one answer. I could
But
put that in Moodle and it would be correct.
Could you like move it so you could use the 1/8?
I could, exactly. And the one disadvantage of this is I had to use fraction there, right? But what if we said, well, we don't want to use that fraction. What if we want to use this point right here to be a?
You would
We
have
could.
to-
We could. Yeah, that's a
You have
good
to use
idea.
the h, right?
Wait, but
Yeah.
why would you do that?
Okay, well, here's why. Here's why. You'll see it's the same answer. You don't have to. It's totally up to you. But you could. We could use this to be the y-axis, right? And that's going to be 8 times 3. But this time we actually, to do that, we had to shift everything where?
To the right.
To the right by 1, didn't we?
Yeah.
Right? Does that make sense? So this would be x minus 1.
Would it be plus
So you can just make it easier for yourself?
I don't know which one's easier. People might say that's easier because all you do is plug in values. Maybe that one's a little bit tougher to use as a model because it has a fraction there. But they're equivalent ways to write this.
Wait, so for Moodle on the assignment, are we just like, you're gonna give a graph like that and then like you either give the purple or the blue answer? Okay.
Yep, and either
Then
one
we
would
don't have to choose
be correct.
Mr. Wyatt, do you have a graph paper?
Do I have graph paper?
Yes.
Yeah.
Why don't you have to move it over to the right in your equation?
What do you mean right here?
Like k. Why is there a k?
Well, because it hasn't been slid vertically.
But hasn't it though?
No. Because look, see, if I choose, what I could do is I could assume that it started at 8, but I just slid everything 1 to the right to get this. See what I'm saying?
Yeah.
But I don't have to. I could just leave it as, that's my A, right?
Oh, so you're like moving the line.
Yes. So we could use a more convenient point for A.
Okay.
That's the only reason we would do it. Okay, yes?
So I was looking at the assignment, and then later in it has questions like a company's profit.
Yeah, those are super easy. Let's look at those, yeah.
I didn't understand.
Okay, so stuff like this, determining, these are the examples. I think there's like 5 questions that pop up that say, well, there's another one too. We'll do both of those. So what about these? Determining constant multiplier. Here's something I don't think I told you guys on Friday that just, it kind of ran out of time. But here, I'm going to add this now. There's 2 ways that we can write exponential functions. We can write them in the traditional way, where we get a times b to the x, where b is what we call a constant multiplier. And we know how to deal with that. We know that if b is greater than 1, it's growth. If it's between 0 and 1, it's decay, right? The other way we can do this, and you might wonder why, but you'll see in a second why this is so useful, is we could write it like this, where we, instead of calling it a constant multiplier, we call it a growth factor. And if we do that, we have to, we're considering R to be a percent. A percent change written as a decimal, okay?
So decrease is positive and increase is
So, exactly, yes. So for example, let's take this one, I'll just pull some up. So let's take one like this. Like say we've got a situation, can everybody read that? Where it's gaining, let me make it a little bigger, where it's gaining 67% of its mass each week. So gaining is increasing, right? Okay, so if gaining is increasing, this is growth. But what I have to do, if I want to write this as, right now it's written in terms of a percent change, right? So 67%, that corresponds to, okay, so 67%, written as a decimal, what is that? 0.67. So if I wrote this as a growth factor, it would be it'd be A times 1 plus 0.67 to the x, right? If I want to write this as a constant multiplier, what do I trade it for? What is that? 1.67. See my point? 1.67 is your answer. Because the percent growth written as a decimal is what's added to 1 if we write this as a growth factor, right? So if we're writing it in terms of percents, we're writing it this way. If we're writing it in terms of just a constant multiplier, we write it this way. But they mean the same thing. But when you're given a question that's written in terms of, or you're discussing growth and you're talking about it in terms of percents, you're always talking about it this way, okay? And that's useful because we think about things in terms of percents. If we say that the money in your mutual fund has increased by 25% in the last year, what does that mean? You got a quarter more. That's easy for us to right? It's a little bit harder for us to say, well, the growth factor or the constant multiplier was 1.25. That's a little bit harder for people to visualize. I mean, probably for you guys it'd be fine, but for most people, they like to think about it in terms of percents, right? And so that's why we have these two different ways of saying the same thing. Let's look at a couple quick examples of this. So that one's 1.67. You just tell me the answers to these, and we'll type a few in.
But you don't have to have the X in there.
No, all it wants, it just wants to know only what's the equivalent constant multiplier. So it would just be 1 point. What's that? 5 questions of it, or just like this. Yeah. So there's that one. Let's do another one. Start again. Okay, what's this? Gaining 44%.
Can we have a whole test just on
You like that, do you? Probably. Take me 6 tries to get ahead. Okay, what's that?
1.04.
Okay, how about
Wait, don't you just subtract
How about that?
it? So 1 minus point.
63.
So what's it gonna be?
0.60.
That's it. Right. Because it's depreciating, right? So that's gonna be decay, agreed? So if it's decay, we're gonna subtract the decimal from 1. So our answer, right? So our answer. What is it?
Yep.
Okay. That's it. Okay. Now here's a tricky one. What if I said your rate? Okay, it increases 200%. What's the constant multiplier?
32.
It's 3. How come?
Because it's 1 plus 2.
Okay. 200% as a decimal is 2. It's 1 plus the decimal, right? So increasing 200% would be a growth factor of 200%, but it would be a constant multiplier of 3. Yeah. It would. It'd be 3. If you're looking for the constant multiplier. Yeah. Okay. Okay. Word problem.
Oh, well, we're doing word problems?
There are a couple of these on there too. Okay, please don't get sidetracked. This is you will regret it if you do. We want to get through this. Oops, wrong one. Let's pick one of these. That's right. Okay, this.
Wow, way too far.
Okay, these are, honestly, these are super simple. They really are. There's not much to these, but you would have had a hard time with them if you didn't know about the growth factor stuff, right? So let's do one of these together, just to show you. So Alden owns a car that is currently worth $26,000. This type of car depreciates at a rate of 9% each year, okay? Fill in the blanks to write an exponential function that represents this, where x is the number of years from now. All right, so what are we going to put, what goes here?
26 times.
Yeah, that's the y-intercept. Remember what that really means is the initial value. So 26,000. What's going to go there?
A year.
0.09.
No.
Wait, would it go the year?
Oh.
Is it,
Somebody raise a hand. Let's see hands. Yes, sir.
Would it be point,
Isn't it 0.91?
0.91. Everybody see that?
why? No.
Okay, because.
Do
Listen,
little
please.
change.
Listen. Because if it's depreciating, that's decay, right? It's going down 9%. Well, by what we just talked about, if we want to write that as a constant multiplier, we have to add negative 0.09 to 1, or subtract 0.09, right? So that's got to be 0.91. Okay? No, but you should get in the habit of doing that. Trust me, that is a really bad habit to get in the habit of skipping that. Because later on in life, you just want to make it just like second nature to type that 0. You'll miss so many decimal points if you don't.
And then it's just x, right?
X. Good. So
And then
that's
just plug that into your calculator.
that's it. Exactly. All we have to do, if we want to come up with the answer to part 2, is plug that stuff into the calculator. That's it, right?
Okay, I like these story problems.
Yeah,
Not
we're-
like, but they're
you-
not hard.
They're not hard, are they?
Are we done here today?
No, we're not. We're not today. We're not going.
Okay.
Okay, so here's the last new stuff I've shown you, and it is honestly, this is probably the easiest stuff yet from chapter 8. You'll agree. Watch. Okay, we talked about this. I can't remember how far we got on Friday, but this is kind of where we sort of left off. I want to just review this real quickly. We have these 3 properties of logs that do something important for us. And here's a way to sort of conceptualize this. If you think about arithmetic, and we define the arithmetic operations, that's really just the PEMDAS stuff. If you kind of think about it in terms of the level of complexity, at the very bottom you've got addition and subtraction. That's easy to do. One rung above that on the ladder would be multiplication and division, right? And then the next rung up would be exponentiation, taking things to powers. That makes things a little more complex. What properties of logs do for us, and we take great advantage of this, for example, in calculus. There's a whole technique called logarithmic differentiation, where we just take the logs of both sides of an equation to take advantage of these properties to make the calculus a lot easier, and at the very end, we'll just kind of move back. We do that kind of stuff a lot in math. Look what these do. They take everything one rung down on the ladder. So if we start off with the log of any base A log of a product, x times y, look what we get back. We get back the sum of the 2 individual logs. So effectively what we did was we turned a product into a sum, making things easier, right? So the base A log of x times y equals just the log of x plus the log of y, okay? Same thing is true for a quotient. If I take the base A log of x divided by y, that becomes the log of x minus the log of y, right? So that's good. We took products and quotients and made them addition and subtraction. Here we're taking the base A log of an exponential function, right? Not exponential function, but of a power function. It's got an exponent, right? The base A log of x to the n, we can turn into n times the log of x. In other words, all we do is we just take this exponent, put it out front, and multiply, right? Very helpful, okay, very helpful. So these kinds of problems are really easy to do. All I'm going to ask you to do is just to start with a big complicated logarithm, not that complicated, and expand it using these properties, or start with an expanded logarithmic expression and condense it into one log. So do this one for me. What would be, we'll start really easy. How about this? What, the natural log of 13x would be what?
Oh, and
13, log 13 plus log.
That's it.
can you scroll it up a little bit so
Sure.
we can finish writing? So what do? We type in L and?
Yep.
Okay.
Yep. And then it'll recognize that as being natural log. Okay? Yes.
Okay, never mind.
Try another one. Try another one.
What do we
What's the, what if I write log that way? What if I write the log of 3x to the 5th? What does that imply? What base am I implying there? 10. What base did I imply here? E. Good, right?
What?
Ladies. Okay. Right, this implies E, that implies 10. If we don't write a base, they're implied bases.
What do you mean by E?
That's the natural number E, right? It's just, if it's not ringing a bell, it's no big deal. It's like pi. It's just that we write it like this. It's just a number like pi. It's an irrational, natural number.
Okay.
Okay. So what's this one gonna become? Okay, well, hang on, let's get hands, right over here.
5 times the log of 3 plus the log of x.
Okay, almost. Now this is, and I was kind of hoping somebody'd say that. Because you have to follow the same kinds of order of operations when you simplify logs as you do normally. So before we can get to the exponential, before we get to this x to the 5th, how are these two being joined? They're a product, right? So the first thing we have to do is we have to simplify the product, and then we'll work on the exponential, okay? So this is gonna look like the log of 3 plus the log of x to the 5th. And now what can we do with that x to the 5th? Bring the 5 out front, right? So our final answer would be, our completely expanded form would be log 3 plus 5 log x. Done.
It's actually really that hard.
No, they're not. They're not at all. And this stuff, I know this stuff seems probably kind of weird, but you just have to take my word for it for now, because we're done for the year. But this is really, really valuable algebra, even though it's not very difficult. You'll use it a lot more in the
The
future.
bottom one is the final answer.
Yes.
And it's the, why does the 5 go? Oh,
Why
it's
does the-
5 of the, okay,
Right, because it's an exponent.
that makes sense.
Okay, Betsy.
Thinking at the end of the year, we can have a final.
Yeah, the final, remember, for you guys, the final is just gonna be an at-home final. That's all it's gonna be. It will be up today.
And unlimited attempts.
Unlimited attempts,
On the final?
yes.
And it's at home.
Wow,
That's
I
it.
can't
Well, I
remember.
mean, it's your, let me clarify. Your last test is an at-home, yeah. The final is technically, listen, hey, you guys are really, you know what, we're not gonna get through this today, which is eating into your lap time. And it's, you know, it's a handful of people's fault, which is really kind of pitiful. It's, the last test is chapter 8 test. The final is technically gonna be the compass test, which can help, I will make you the deal that if you do well on the compass test, I will reflect that back on your lowest test score, okay? So it's a deal that really, it can only help you, it can't hurt you.
So if you
You
do
can
bad,
take it as much as you want.
No, compass
what
test
if
you
you
can
do-
only take like
what if you do bad
maybe twice, yeah.
on the compass?
Well,
That,
if you do poorly on the compass test, the only thing, it's not gonna affect your grade in here so much, but you don't want it because it places you.
yeah,
And
in
it gives,
college.
it gives you the opportunity to get college credit next year, yeah. So you have to do well to get into
Is it
pre-calculus.
extremely hard?
No,
Is it,
no, you guys are gonna have no
don't
problem.
you, like, is
Same
it like
amount of
6
credit
plus
as you
7?
do in college?
No, but it's just you, here, let's, the compass test, I tell you what, if we want to, we can take half a period in here and I can just tell you kind of what's on it and we can maybe, there's one topic I would potentially want to review with you, but that's it. Everything else you guys are awesome with and there's no.
Are you just saying that? or-
No. We do this every year.
Because I've forgotten everything.
Well, if you really don't think you remember stuff, what you might want to do is you might want to go back and just kind of breeze through, hit the high points in your book. You know, just how do you solve linear systems? How do you, it's stuff you guys know how to do. Well, you might want to just study a little
Could you
bit.
put up your?
No, I can't. It doesn't work on Moodle. What?
When are we taking that?
It's either next Monday or Tuesday we start. Okay, yep.
But not, because you want to get into pre-calc trade, but not saying you shouldn't, but don't you get the same amount of credit, like college credit, as you do college algebra, as you do?
No, you get more pre-calc trade.
Well, I
Okay.
heard that college algebra is still a good class.
Yeah, it is.
I don't want
It is. But you guys should all, I mean, you need to set your sights for pre-calculus.
Okay,
Everybody in
but
here. Yeah.
This
Yeah, they're
class
both.
just got stressful.
Well, no, listen. Let me say this very clearly. You guys, you just have to believe me on this. You don't really have to worry about that test. It's going to be, there are going to be some people, I mean, you guys are so far above the level of stuff we do in here, the regular, just like the normal Algebra 2 class. The honors class is really an honors class. And there's going to be some people in there that are going to test into pre-calculus or above. So you're not,
That makes sense.
anybody can have a bad test. It's not a great test, I'll tell you that right now too. It's really not a great test. I don't want you to feel bad if things just, if you just had a brain fart and things didn't go well, or if you got unlucky. And the test, the way it stacked out for you, it might. But I think I can probably give you 2 attempts. And don't stress about it, really, don't stress about it. Here's the other thing too. You could come back if you wanted to, you can just go to Blue Mountain and pay your $10 and take it again. Review over the summer and go back and take it in the fall if you want to. It's fine. All you have to do is before next year, you just have to have gotten the score that you need to be in pre-calculus. And there have been people in the past that for whatever reason, that should have easily passed, that just had a bad day and didn't. And they just go back and, wait a month and let their brains clear and go take it again and they do fine. So there's nothing to worry about. Really, it's not a high stress test. You guys are gonna be fine anyway, I promise you, yeah.
No, because like, you know how I test and how like I stress out a lot and I have to like calm myself down and I end up forgetting and stuff? Like, because I have to, I know these when we learn it, but then I forget them because I stress.
Okay, what I would say is, everybody take, before the test, everybody take 10 deep breaths, and you just take about 25. Yeah, I think you'll be fine, really.
Do you remember when I was taking oaks and I had to have like little special thingies I had to do?
You're gonna be
I
fine,
like how we
really.
pie day before we take this test.
Have
We
what?
bring in pie and we stop.
That's a definite possibility, yeah, all right. Okay, so now, but listen. We'll talk more about this, but I wanna, let's see if we can wrap this up. I really would like to get you in the lab as much as possible, because that will also reduce your stress. So one kind of problem is going to be, start here, and there, okay? The other kind of problem is gonna be, I give you this, you give me that, okay? No big deal.
That's really easy.
Yeah, okay.
Wait, is the compass test,
Back to the compass test.
sorry, is the compass test multiple choice?
I don't even remember. A lot of it's multiple choice. It's really, it's kind of a weird test. I'm not a huge fan.
Why are you saying?
It just is. It's supposed to be this
You're doing
adaptive
an essay?
test. No.
Oh gosh, I hate you.
Yes.
Does it give you like a median feedback for it, right? Or does it wait for the end?
It doesn't, no, not till the end.
It's like
We'll talk more about it, but just don't panic. You're fine. Okay, here's the other thing. Look here, please. Here's the last issue. And I kind of saved the best for the last year. I mean, the most important for the last. Here's where we actually, very soon, you guys will be in situations where you'll need to be able to expand your ability to solve equations. And really, all we're doing here is we're taking the same process we've used all year, which whenever we can, remember, if we can point to a single x, what can we do?
Solve it.
We can isolate it, which means solve it, right? We've just kind of added to that basic core structure all year long. We just recently, we talked about, for example, in the last chapter, we talked about how we could take, roots of both sides of an equation, right? Like instead of just taking square roots, we could cube root both sides or ninth root both sides. But we're still just isolating x. Is that us?
Yeah.
Okay, we got 5 minutes tomorrow and then we'll be. All right.
Okay, so would x be 3/2?